Hi everyone! In today's video I will be going over the Unit 5B study guide. Alright, number 1 and 2. Write the expressions in radical form. So this is just switching between different forms. So we have 25 to the 2/5 here. Remember, this fraction means it can be written as a radical. And then remember, the fraction represents in over out. So the number on top goes inside the radical with the base, in this case 25, and the number on the bottom goes outside the radical. So we make our radical, and we write 25 underneath it, our base, and then inside with the 25 is the 2, and then the 5 goes outside. If it helps, I always think of the top exponent being the exponent that goes on the 25 itself, so then 5 has to go outside. That's the only other place it can be. And that's all you have to do. 6 to the 1/3, same thing. 6, 1 goes inside with the 6, in over out, 3 goes out. Now technically, we don't keep an exponent of 1, we drop it, because it's the same thing. So technically that is the full complete answer, just the cube root of 6. Number 3. Simplify each radical expression, show all work. So we have to break these down as much as possible. I've already gone through and done these problems one time, and I'm going to warn you, I don't have as much space here as I would like, so I might have to write a little smaller than I'd like to. Just going to give you that heads up now. Okay, so I like to focus on breaking these down one at a time. Take note that number 3 here, we have a square root. This is the square root of 100x squared y to the 9th. So we have an implied 2 there. If it's not there, that means it's 2. If we do have a number there, like a number 4, then you go by what that number is. So let's break this 100 down. So you make a factor tree, and you think of two numbers that multiply together to give you 100. So you could start with 2 and 50, 25 and 4. The best two numbers to start with that are going to get you to your answer quickly here, and I think a lot of you would come up with this anyway, so these are the two I'm going to use. 10 and 10 would be the easiest route here. Now, if you didn't come up with 10 naturally, if you came up with one of those other factors I just mentioned, 25 and 4 or 50 and 2, work with those, break it down, and then see if you'll get the same answer that I am going to get. It still works. You're just going to have a little bit more work involved. Okay. So, the reason 10 and 10 are the best one is because if you didn't realize, 100 is a perfect square, and the square root of 100 is 10. So this is my pair, because you want two of the same number. I am already there with the 10s, so I'm going to stop at the 10s and circle those. If I break them down, I'm still going to end up with the same thing. So once I get my pair, and I don't have anything else here to break down because of the 100, I can stop there with the 100. So my pair is 10, so 10 can come out of the square root. So right now I'm setting up my answers. I'm going to do 10, and then I'm going to go ahead and write the square root. So I'm setting up my answer. I'm leaving space here for some letters just in case, and I'm leaving some room here underneath. Remember, it's just a 10. There's no other numbers, so I don't write any numbers under the square root. Now the letters, I come over here and I work out myself. X squared. X squared is the same thing as just having two x's. Again, we're making groups of 2, and I do have 2 x's, so the x can come out, just one x, and there's none left, so there won't be any under here. Y to the 9th. Now, I'm going to show you 2 ways to do this, because if you were to look ahead of the other problems real quick, you'll notice some larger exponents. So doing this isn't ideal when you have large numbers. We're not giving you anything like too big, like too ridiculous, where if you wanted to write the letters out that many times, you could if you wanted to, but just comes a point where I'm like, okay, let's actually do it this other way. So I'll show you 2 ways here right now. So you can write out 9 y's, 1, 2, 3, 4, 5, 6, 7, 8, 9. Even 9, that was a little much. So you circle, you make groups of 2. Got 1, 2, 3, 4, and I got one guy left. So 1, 2, 3, 4. 4 y's come out. 1 stays under. And this is my final answer. Now, I'm going to go ahead and show you the other method, because the other method that I'm about to show you, that's how I'm going to do my other problems. So, the other way to do it, if you haven't caught on to how this method works that I've been using, you're taking however many x's or y's you have, so we had 2 here, 9 here, and you're dividing it into groups of 2 because that's what our radical is. So we're dividing that number by 2, essentially. Now, when we have an odd number, that obviously gets a little tricky. So, the other way to do this, didn't mean to write the equal sign. You have y to the 9th. So we do 9 divided by 2. Now we divide this. And whether you do this in your head or on paper, I'm going to do it on paper. Don't do this in the calculator because this will cause a bit of confusion, because you'll get a decimal. You just do division like normal. Like a long division, but very short division. So how many times does 2 go into 9? It goes in 4 times, because 2 times 4 is 8. And you subtract and you get 1. So we get 4 remainder 1. That means 4 y's come out, and we have 1 left under. It's the same logic that I used up here. So this is great when you have larger exponents, which we're going to have in just a moment. So I'm going to start doing this more often. If you want to keep writing them out and circling, that's perfectly fine. But there comes a point where this is much quicker and easier, in my opinion. So, that was explanation number 2 for the y's. There's our final answer. Okay, number 4. We have a cube root here. Notice the 3. So when we make our circles, here, because I'm not going to do them with the letters, we're looking for groups of 3. Negative 343 y to the 18th. See, that's 18. If you want to write out 18 y's, be my guest. I'm not going to. Okay, let's break down the number first. First off, everyone gets so tripped up over the negative. First off, when I do have some Post-its handy. Thank the Lord. Let me demonstrate. Let's do negative 2. So I'm doing a different example right now, so ignore this for now. Come to here. Negative 2 cubed is negative 2 times negative 2 times negative 2. And I'm going to do this in 2 steps just to demonstrate the point. Negative 2 times negative 2 is positive 4. Positive 4, because negative times negative, positive. And then when I multiply that by a negative 2, it turns it back into a negative, and it's negative 8. So when you have an odd number of negatives, because of that 3, your answer will be negative. So when I cube root, which is the opposite of what I just did here, I'm going to have a negative come out of it. So to make this easier on you, when you see a cube root and you have a negative underneath, go ahead and put that negative in your answer. I'm going to build my answer down here. That way, when you break this down, you don't have to think about that negative. You already have it accounted for. It makes things far less complicated. Okay, 343. That is a fun number. Let's think of numbers. If you don't have a calculator out, pause the video, get out a calculator, and then continue watching. We just need to go through different numbers until we find one that we can divide 343 by and not get a decimal. Obviously, it's not even, so I won't start with 2. I'm going to start with 3. Nope. 4. Nope. Hopefully it's obvious that 5 does not work, because this does not end in a 5 or a 0, but test it just in case. It's still not a whole number. 343 divided by 6. Nope. 343 divided by 7. Bingo. You can usually find your number between 1 and 10. If you can't find it, keep looking. So, divide it into 7 and 49. Okay? 7 can't break down any further. The only 2 factors of 7 are 1 and 7. So I'm done with 7. But I can break 49 down. Hopefully, 49, you automatically think of 7 and 7 because Those are the only two factors that we can use here. The other two are 1 and 49, and that's not allowed. So, by the way, if it helps you keep track, once you break a number down, go ahead and cross it out so that you're not focused on this when you're trying to figure out what you need to collect, if that makes sense. So again, I stop with these 7s. So now in my tree, I want groups of 3. Well, I do have 3 7s, and that's all I have. I don't have any numbers left. So I can pull the 7 out. 7 comes out. So this is a -7. And then no numbers left, meaning nothing goes under this radical. Now to set up my answer, I am going to go ahead and put a radical there just in case I need it. It's a cube root because that's what we have in the problem. Leave some space in case some y's come out, which there will be some y's that come out. Okay, I broke down the 343. Let's break down the y's. Y to the 18th. So again, I need to break up 18 y's into groups of 3. So 18 divided by my radical number, which is 3. Hopefully most of you recognize that 18 divided by 3 is just 6. If you don't, you can set up the full division problem. 18 divided by 3. How many times does 3 go into 18? 6 times. And then when you subtract, you've got nothing left, no remainder. So 6 y's come out. So we have y to the 6th. And look at that, no y's are left under the radical. There's nothing under this radical. So actually, I didn't even need it. -7y to the 6th is my answer. No radical left. Number 5. We got a lot going on here. 4 square root of 3a to the 6th b squared times the square root of 12a to the 7th b to the 6th. Again, this is a square root on both of them. Since these are both square roots, go ahead and do the operation. Go ahead and multiply. Get one radical and then break down that one radical. 4 in front, we've got nothing in front. It's a 1 if you want to get technical. So we're just going to have 4 there. Radical, and we're going to put all this together. So multiply the like things. Those 3 and 12, multiply those, you get 36. A's, you can multiply. A to the 6th times a to the 7th. Remember, when you multiply the bases, you add the exponents. So this is not 6 times 7, this is 6 plus 7. That's a to the 13th. And then the b's. B squared times b to the 6th, multiply the bases, add the exponents. 2 plus 6 is 8. B to the 8th. So now, we can break down the 36. And before I do that, I'm going to go ahead and set up my answer down here. And the reason I want to set up my answer and go and get started is because I have this 4 in front, and this is very easy to forget later on. So if any numbers come out, I'm going to multiply the 4 by that. So I'm going to put a times there just in case. All right, 36. 36, you have options here. You've got 3 and 12, which I'm sure most of you, that wouldn't be your first thought. 3 and 12, you got 9 and 4. Hopefully, most of you think of 6 and 6 first, because that is kind of the common two that come to mind. That's what comes to mind for me. And again, I hope you come up with 6 and 6 first, because those are already a pair. I've got the same number twice. And again, we're looking at pairs of 2 here, because we have a square root. So if you can make a pair right out of the gate, you're done. And again, hopefully you might have already noticed, hey, I've got 36, and I know 36 is a perfect square. It's 6 times 6. So I can pull this pair, 6, out. So I pull out 1 6. So now I've got 4 times 6 now. That's why I set it up that way. I'm setting on my answer down here. I'm going to go ahead and add, probably gave a little too much room there, but that's okay. Add a square root in the answer in case anything has to go under here. So right now, all the numbers are out of the radical. Now I break down the letters. A to the 13th. Again, if you want to write out 13 A's and circle groups of 2? Be my guest. I will not. So we're going to use division. We're dividing this into groups of 2. So it's 13 divided by 2. So I'm going to do division. So I have 13 divided by 2. How many times does 2 go into 13? Well, I can get to 12. 2 times 6 will give me 12. Subtract, and we're left with 1. So this means 6 A's come out. So I've got a to the 6th here. And 1A is under the radical. Now the B's. B to the 8th. Again, if you want to write out 8 B's, that's not too bad. You can do that. Remember, we're dividing these 8 B's into groups of 2. Hopefully you recognize, oh, that's just 4. 8 divided by 2 is 4. So that means we have 4 B's, no remainder. So 4 B's come out. So we have B to the 4th out here. No B's under the radical. We were able to group them all together. So lastly, if you end up with something like this, do not leave this as 4 times 6. Please turn that into a 24. So my final answer is 24, a to the 6th, b to the 4th, square root of a. Just take your time with these, step by step, and you'll get there. Okay, number 6, we have division. Make sure that these radicals are the same. They are both a cube root, so I can divide them. And please do that. Go ahead and divide. Get one radical, then break that down. So I've got a cube root. 40 divided by 2 is 20. X to the 11th and then x to the 2nd. When you divide the bases, you subtract the exponents. 11 minus 2, that's just 9, so x to the 9th. Y to the 6th over y cubed. Subtract 6 minus 3 is 3. So we've got y cubed. Okay, so now we take our time, break it each part down. Break the 20 down first. Notice we are breaking them down into groups of 3. We were looking for a group of 3 of the same number. 20, you've got options here. You've got 10 and 2. Maybe, like me, you thought 5 and 4. Which this is good because these won't take long for me to break down. 5 can't be broken down, so we're going to keep it. 4 breaks down into 2 and 2. And again, I can't break those down, so I'm done. Done with that 4. I have 2, 2, and 5. Well, I've got 2 2s, but remember, I need groups of 3, not two groups. So actually, I can't make a pair here. So while this looks bad, this means I can't break this 20 down. I can't take anything out from the 20. The 20 is just going to stay a 20. So, if you want to think about it as multiplying this back together, 5 times 2 is 10 times 2 is 20, you can do that. But basically what I'm saying here is this led me nowhere. So, I can't actually do anything with that. So let's set up our answer down here. So we know for a fact this 20 is under the root, and that's fine. Sometimes it doesn't work out that way. Sometimes it does not work out for us. It's just like that. So the 20 stays under the root. Now we could bring out some letters, and we will bring out some letters in a moment. So now let's work on the letters. X to the 9th. Again, write out 9 x's and circle groups of 3 if you'd like. Or just take that 9 and we're going to divide it into groups of 3. So 9 divided by 3. Hopefully you recognize, hey, that's 3. That means 3 x's come out and I don't have any left. So I'm going to come out here, leave some room for some y's. X cubed is what comes out of there. Now I repeat with the y's. Y cubed. Again, we're going to divide that into groups of 3. So 3 divided by 3, hey, that's 1. 1 y comes out, I don't have any left. There's my answer. I'm going to rewrite it because that looks a little, if I had a pencil, I'd just erase it. So it's x cubed y, and then it's the cube root of 20. And I'm done. Side note, especially on the test, when you're writing out your answer, Make sure it's clear that this cube goes inside the root and is not accidentally attached to this y, so it doesn't look like a y cubed. That's very easy to do. So if you need to create more space between the two, like I did over here, you can do that. I made sure I really tucked that into there, so there's no confusion. This is just a cube root. All right, number 7. These are the ones where I'm going to have a little issue with space, just because the trees are going to kind of take up a lot of room. So I'm going to try to write a bit smaller on these. And in fact, I'm going to switch to a slightly thinner pen for that reason, so I can write a bit smaller. 5 square root of 3 plus 7 square root of 180 minus the square root of 48. So, reminder, when you're doing addition and subtraction, you can't combine these unless the number under the radical is the same. So I'm very limited on what I can do here. Since I can't combine anything, let's break down some of these bigger numbers and see if I can come up with something that can be combined. Obviously, the 3 can't be broken down further. That won't get me anywhere. So we're going to leave this alone for now. And actually, I'm going to bring it down. We'll go right about here. Hopefully, this will be enough space. 180, that's a pretty big number. I can probably break that down. 2 good factors to start with 180. Hopefully you notice the 0 at the end. That means you can divide this by 10. If I do 180 and I divide it by 10, that's going to leave me with 18. So those are 2 solid numbers to start with. You can start smaller than that. You could have started like, hey, that's even. So you would have done 2 and 90 to start with. Now that 90 was going to take a while to break down, but if that's what you started with, that's fine. You'll get there eventually. So 10 and 18, pretty solid. Let me break these down individually. 10, well, I've only got 2 numbers that I can use, 2 and 5. 10 is broken down, so I'm going to mark it out. I'm stopping with 2 and 5. 18. You can do 6 and 3, or hopefully you thought of, well, actually, it doesn't really matter. You can do 2 and 9 or 6 and 3. You'll get there either way. I'm going to do 2 and 9, though. Slightly more straightforward. 2, I'm going to stop there. And then my 9, I can break it down one more time into 3 and 3. And then I forgot to cross out the 18. And then the 9 I've broken down, so I'm going to cross that out. We've broken it down. So now, again, this is a square root, so we are making groups of 2. Now this is going to look a little weird, but it's going to work. I can circle a group of 3s, and then I have a pair of 2s. They're just not next to each other. Okay. So I've got a group of 2s, a group of 3s, and then a single 5. That means the 5 cannot come out of the radical. Now remember, when you put this together, you end up multiplying these 2 numbers. And let me backtrack a little bit. So I'm going to continue with my answer down here. Plus, I've got that 7 on the outside. Very easy to forget. And then I'm going to multiply that 7 by whatever comes out of here. So we got a 2 and a 3. When I take these out together, I need to multiply them by each other. So this is 2 times 3, which is 6. So 6 total comes out. 2 times 3 gives me 6. 5 is left, so that's going to be under my radical still. And now I'm going to, with what little space I have left, break down the 48. Go ahead and bring down that minus so you don't forget about it. Okay, I'm going to kind of move my tree over here just because I'm running out of space going down. 48. You've got options again. Hopefully the first 2 that come to mind are 6 and 8. You could have started with 2 and 24. That's fine. It'll just take you a little bit longer to break it down. Okay, so 6 breaks down nicely. That's 3 and 2. So my 6 is done. It's kind of a sideways tree. And then 8 breaks down into 4 and 2. 8 is done. 2 will stay. And then 4 I can break down one more time into 2 and 2. And now I'm done with the 4. So I've got 2, 2, 2, 2, and 3. Okay. Again, this is a square root, so I'm making groups of 2. So I've got one group of 2, got another group of 2, and then I've got a 3. So I'm going to go ahead and put that 3 under the radical where it belongs. Leave some space in front of it. So I've got one pair of 2s and 2 pairs of 2s. So I've got 2 times 2, which is 4. All right. Now, I'm going to rewrite this one more time because I want to take care of that 7 times 6. So I've got 5 square root of 3 plus, this is now 42 square root of 5 minus 4 square root of 3. All right. Lastly, I'm not done. If we look at the new numbers we do now have 2 numbers with the same radical. This 5 and this 4 both have a radical 3, so I can combine these. So when you do that, my final answer is going to be over here. That's where I have space. You do the math with the numbers in front, you keep the radicals. So I'm going to go ahead and write that radical 3 there, because that is not going to change. So we have 5 minus 4, that's a 1. So you can write this as just the square root of 3, or you can put the 1 in front. They mean the same thing. And then bring what's left. So this 42 square root 5. I can't do anything with it, so it's just kind of hanging out there. And then these 2 I combined and got 1 radical 3. This is my final answer. All right, number 8. We got another one of these. And I got a little bit more space to work with, so should be a little less cramped over here. Same kind of problem. Square root of 50 plus 7 square root of 2 minus the square root of 72. Again, we don't have the same radical, so we got to break these down. The good news is the 7 radical 2 can't be broken down, so I don't have to worry about that one. Let's start with the 50. 50, there are 2 pairs of factors that come to mind, 5 and 10, because we got that 0 at the end, or 25 and 2. Again, you can't go wrong either way. 25 and 2 will be the slightly, and I mean slightly faster way. Really, there's really not a better pair. I mean, 5 and 10 will break down very quickly too, so it's a win-win regardless. 2, can't do anything, so we keep it. 25 can only break down into 5 and 5. And 5s can't break down. So I've got 5, 5, and 2. Reminder, this is a square root, so we need groups of 2. I have 2 5s. And then I have a singular 2, so the 2 has to stay out of the radical. And then I've got a pair of 5s, so 5 can come out. 5 radical 2. Bring down the plus 7 radical 2. Can't do anything with it. And then let's break down. Let me bring down that minus before I forget. Let's break down the 72. 72, you have some options here. You got 2, and I think that would be 36. You could do 2 and 36 if you wanted to. But if you're really thinking about factors, most people will think of 8 times 9 as the first pair of factors, and those are a good pair to start with. 2 and 36 would actually be pretty easy as well, but options. Okay, 8 breaks down into, I'm intentionally writing them 2 times 4. So that the 2 will stop here and the 4 will keep going. By the way, if you did 4, 2, it still works. That doesn't matter. Okay, so I've broken down the 8. 2 times 4. 2 stays. 4 breaks down into 2 and 2. And then 9, I'm going to kind of branch over here a little bit. 9 breaks down into 3 and 3. And then 3s stay. So again, this is a square root, so I'm looking for groups of 2, and we got a couple. I've got a group of 2 3s and a group of 2 2s, and then a singular 2 left. So this 2 is going to go under the radical still, can't do anything with it. And then I've got a pair of 2s and a pair of 3s. Remember, you multiply these together and put them on the outside. So this is 2 times 3, which is 6. So this time, when I broke all these down, I ended up with the square root of 2 on all of them. So all of these can be combined. So I'm going to do them 2 at a time. I'm going to start with the first 2. 5 square root of 2 plus 7 square root of 2. Remember the square root of 2, you keep it. And then you just do the math. So 5 plus 7, that's 12. I'm going to bring down minus 6 square root of 2. Final answer will go over here. 12 square root of 2 minus 6 square root of 2. Again, you keep the square root of 2. You don't actually do any math with it. It just stays. 12 minus 6 is 6. 6 square root of 2 is my final answer. Number 9. 2 plus 4 square root 7 times 4 plus 5 square root 7. Just because I crowded my space up here, I'm going to rewrite the problem so I can demonstrate what I want to without things being in the way. All right. So, when you have this set up, you have to use the FOIL method, or I like to personally call it double distribution because that's what it is. You multiply, you distribute the first term fully over here. So I'm going to do those two numbers first. So I have 2 times 4, that's 8. And then 2 times 5 radical 7. So remember, when you're multiplying, you multiply the outside numbers. So 2 times 5, that's 10. It's a positive 10. Square root of 7, I don't have another square root to multiply, so I just attach it to my answer here. So those two came out of that color, and I'm going to do a different color to do my next two. So I distributed the first number, now I'm going to distribute the second number. So you distribute it fully into the parentheses. So now I have 4 square root 7 times 4. So 4 times 4, it's going to be a positive 16. And then again, just attach the square root 7. And then 4 square root 7 times 5 square root 7. So first you multiply the outside numbers, 4 times 5, that's going to be a positive 20. And then square root of 7 times the square root of 7. Take your time on this, don't get too ahead of yourself. Let's just first multiply. 7 times 7 is 49. So we now have the square root of 49. So these two came out of multiplying the blue. All right. Now you can always condense a little bit at least. So 8, there's no other solid whole number, so 8 is just going to be 8. My middle two terms both have that square root 7, so that means I can combine these. So you just do the math. So I'm going to have a square root 7 in my answer. And then 10 and 16, when you add those, you get 26. So plus 26. And then I'm going to bring this down. Plus 20 square root of 49. There's one more thing you can do here. Hopefully you noticed that the square root of 49 is a perfect square. The square root of 49 is just 7. So another way to go about this, just be careful with it. If you multiply the same radical by itself, you're basically getting rid of the square root. So it's just going to become a 7, is what I'm getting at. So 8 plus 26 square root of 7 plus 20, and then now instead of 49 under the radical, I'm just going to write 7. One big mistake I often see is students will still put square root of 7. No, we have square rooted it. The square root is gone. It's just a 7. So again, if you want to skip this part and just go, oh, these are the same, so when I multiply them, the radical goes away and it's just a 7. You can do that, just be very careful with it. I'll see some mistakes with it. Okay, so we have 8 plus 26, the square root of 7, plus, now we can do 20 times 7, which is 140. Lastly, we have two whole numbers we can now add together. So we have 140 and 8. So let's add those to get our final answer. 140 plus 8 is 148 plus 26, the square root of 7. I can't add these because this has a radical and this doesn't, so I'm done. By the way, if you flip-flop these, if you put the 26 square root 7 first and then the 148 next, it is still 100% correct. It doesn't matter what order you write them in, but this is typically how you do it. Number 10. be very careful on these problems. 5 minus the square root of 3 squared. A lot of students, most students, are just going to take this squared and they're going to give it to both numbers. They'll do, oh, that's 25, oh, that's 3, and I'm done. No. Remember, this is the same thing as 5 minus the square root of 3 written twice. That's what squared means. It's a number times itself. That giving of the exponent only works if these are being multiplied or divided. We're not doing that here. We're subtracting. So adding or subtracting, you have to do this because you'll get a very different answer if you just give the square. That's how you know it's not correct. So this is how you can check, and this is how you have to do it. So write it twice. That's what squared means, and then we're going to do the double distribution, FOIL, once again. All right. So first you distribute the front term into this set of parentheses. 5 times 5, that's 25. 5 times negative rad 3, remember this is just like a negative 1. So this becomes negative 5, and then just attach the square root 3. So that was the pink, and now let's do the blue. Negative rad 3 times 5, same thing here. We got a negative 1 times 5, that's a negative 5. Attach the rad 3. And then we're going to multiply this. Negative 1 times negative 1, that's positive. So this is a plus. Now you can write one of two things here. If you notice that this is the same radical twice, then you could just go, oh, the radical is going to be gone. It's just going to be a 3. You can do that. Or you could take a couple extra steps like I do and go, okay, 3 times 3 is 9. So this is the square root of 9. 1 times 1, that obviously 1. You don't need to write the 1 in front. I wouldn't recommend that. That's what came out of the blue. All right, we condense 25. We don't have another whole number yet, so we can't do anything with it. And then the two middle terms both have that square root 3, so these can be combined. Negative 5 and negative 5, when you combine that, you get a negative 10. And then attach that radical 3. Plus the square root of 9. Again, at this point, I hope you notice you have a perfect square here. The square root of 9 is a perfect square. It's 3. So we're going to rewrite that as just a 3. The square root is gone. It's not the square root of 3. It's just 3. Bring down everything else. 25 minus 10, square root 3, and then that's a plus in front. Last thing we can do, we now have two whole numbers, 25 and 3. Let's combine those. They're both positive, so we're going to add them. 25 plus 3 is 28 minus 10, square root of 3. And again, we are at a point where we can't combine these because this is a whole number. It doesn't have a radical. This does. So we are done. Okay, let's move on to the next page. Okay, exponent rules. I'm going to read the directions because this is very important. We're going to be very strict on this on the test. Simplify the rational exponents. That's just the directions. Fractions must be simplified. So that means if you have 2 over 4, you do have to reduce that down to 1/2. Fractions must be simplified, and your answers should contain only positive exponents. And this part is in bold is kind of redundant, but I really wanted to emphasize no negative exponents. Negative exponents are a no-no. We talked about in class how to take care of those. We'll talk about them again in a moment when we get there. All right, number 11. R to the 3/5 times R to the 7/5. Remember the rules. When you multiply the bases, you add the exponents. So this is r to the 3/5 plus 7/5. So here's the good news. Remember, when you add fractions, they have to have a common denominator, which we do have here. So we don't have to do much work here at all. When you add, you just add across the top. You keep the bottom the same. 7 plus 3 is 10. And then hopefully you notice that 10 over 5, you can reduce that. You actually divide it. 10 divided by 5 is 2. R squared. And I'm done. Number 12, we got another one of those problems. 3y to the 3/2 times 2y to the 3/4. Let's do this multiplication here with the 3 and the 2. 3 times 2, that's 6. And then let's do the bases. Multiply the bases, you add the exponents. So we have 3 over 2 plus 3 over 4. Now I'm going to need to do a little bit of side work here. I'm going to do it over here. So we have 3 over 2 and 3 over 4. Let's look for a common denominator. We have 2 and 4. We can turn this 2 into a 4. So let's do that. So again, we are adding these. So to turn this 2 into a 4, I need to multiply by 2 on the top and the bottom. So this now becomes, let me backtrack. When you multiply straight across. So this becomes 6 over 4 plus 3 over 4. And then we add, just add the top. 9 over 4. So my new fraction is 9/4. So we have 6y to the 9/4. And then I can't reduce 9/4, so I am done. Number 13. T to the 7/4 squared. This is what we call a power of a power. That's because this exponent, 7 over 4, has its own exponent, it's 2. When they are grouped like this, you can actually multiply them. So this becomes t to the 7 over 4 times 2, and let's make that a fraction, 2 over 1. When you multiply, reminder, you don't need a common denominator, just multiply straight across. So 7 times 2, that's 14. 4 times 1 is 4. 14 and 4, hopefully you notice, that can be reduced. We can divide the top and the bottom by 2, so let's do that. 14 divided by 2 is 7. 4 divided by 2 is 2. So t to the 7 over 2 power is our answer. 14. We've got another one just like 13. This is a power of a power. Something you got to be very careful of here. Notice this 2, that's important. Now this is multiplication. It's all together, all one term, and this is 2 times that m. That means you can give that exponent to both terms. So just to compare on the front from earlier. Number 10. I couldn't do that with this 2 because this was subtraction. When you add and subtract, you have to separate and FOIL or distribute, double distribute. When you multiply or divide, and in this case this is multiplication, that's what it means when they are just written as 1, you can give the exponent. That's allowed. So be very careful with that. Okay, when I do that, this is still multiplication. So remember that 2 has an exponent of 1. So this is 2 to the 1st times 6. M to the 7 over 4 times 6 over 1. I write this one as a fraction because I'm multiplying with a fraction. Okay. 1 times 6 is 6. And then M, multiply straight across. 7 times 6 is 42, over 4 times 1 is 4. 2 things. 2 to the 6, we can put that in our calculator, so let's do that. So I have 2 Reminder, on this calculator in particular, you use the caret, that's this arrow here, to type in any number you want for an exponent. So I want 6. So 2 to the 6th is 64. And then I need to reduce 42 over 4. These are both even. And then if I did 42 over 4 in my calculator just to demonstrate, that does not divide evenly. So the only thing I can divide both of those by is 2. Because we can't have a decimal up here. That is not allowed. So let's divide both of those by 2. 42 divided by 2 is 21. 4 divided by 2 is 2. So 64 to the 21 over 2 is my... Whoa. Sorry. I got to put that m in there. Now let's write our fraction. Sorry about that. 21 over 2. Almost forgot my m. Okay, now that's correct. 15. Now we're doing division. Reminder, when you divide the bases, you subtract the exponents. So this is x to the 3/4 minus 1/2. Different denominators, so I'm going to need to do a little bit of work. I'll come down here and do that. So we have 3/4 minus 1/2. I left space here to do the multiplication if need be. 3/4 and 1/2, my denominators are 2 and 4. I can easily turn 2 into a 4. Let's do that. Multiply top and bottom by 2 to make that change. And then I don't have to change this one, so it's just going to be 3/4 minus 1 times 2 is 2, 2 times 2 is 4, and now we can subtract. 3 minus 2 is 1. Denominators stay the same, don't actually subtract or do anything with them. So this, if we come back up here and put the fraction in, is now just x to the 1/4. There's my answer. Number 16, w to the negative 7 over 2 times w to the 4/3. Okay. I'm going to do that down here, and I'm going to do side work over here. So remember, when you multiply the bases, you add the exponents. Negative 7 over 2 plus 4/3. Different denominators. I'm going to need to do some side work. I'll come over here to do that. Negative 7 over 2. I'm going to leave some space. Plus 4/3. 2 and 3. Well, I can't turn 2 into 3, and I can't turn 3 into 2. If I multiply them together, I get a 6, so I can turn both of these into a 6. So I'll multiply this fraction by 3 over 3, and this fraction by 2 over 2 to make that work. 2 new fractions being added. Negative 7 times 3, that's negative 21. 2 times 3, that's 6. 4 times 2, that's 8. 3 times 2, that's 6. Common denominator, I can now add. Okay, negative 21 plus 8. That is a negative 13 over 6. If you need your calculator to help you with that, you can do that. Okay, so my new fraction is w to the negative 13 over 6 power. 13 and 6, I can't reduce that, so that it's simplified, it's reduced. Remember, no negative exponents. So if you left this as your answer, you would be losing some credit because this is not allowed. Remember, to get rid of a negative exponent, I need to flip it like a fraction. The whole thing, not just the exponent. So write this over 1. And I'm going to butt into this space down here. So you flip it. If this is on top, you bring it to the bottom. So now I'm going to have 1 on top. And this is going to be on bottom, w. And then now I can get rid of the negative exponent. So it's 1 over w to the 13/6. And now I'm done. That is how you get rid of a negative exponent. All right, equations, the last section. Solve each equation, show all work. Be sure to check your solutions. I know we don't like to do this. It's just another step. But I promise you, it'll be worth your while. Make sure you check your answers. And if it comes up correct, then you know you got the right answer for sure. So that's just extra confidence. All right. The square root of x minus 11 plus 16 equals 21. I'm going to rewrite this so I can really work with it. Square root of x minus 11 plus 16 equals 21. Make sure that the 16 is not under the radical, because it's not. Now remember, the first thing to do here to really help you focus on what is the first thing to do is underline what you need to get by itself. So usually that's going to be a square root, or if we take a peek at number 19, parentheses with an exponent, that's something else. Okay. We need to get this by itself first. So we need to move this 16 over here. So that means we're going to subtract 16 on both sides, since it's positive. Those cancel. Now we're left with the square root of x minus 11 equals 21 minus 16, that's positive 5. All right, now that this is by itself, this would focus, that would be great. Oh, there it goes. Now that this is by itself, I can finally get rid of this square root. So, to get rid of the square root, you square. The opposite of square rooting is squaring. And you square both sides. This is important. A lot of students like to get rid of it, but then they don't do it to the other side. That's the golden rule of algebra. What you do to one side, you do to the other. Now remember, this square gets rid of the square root. So now I just have x minus 11 equals 5 squared is 25. And now I just solve for x. I'm going to move the 11 over here by adding it. Gone. X equals, just add these together, 36. Make sure you check, because at this point, as long as my math is correct, it's either 36, or if I find out that this doesn't work, it's no solution. So those are still options. So make sure you check. We're going to check. I'm going to come over here to do that. So we are checking x equals 36. I'm going to write down the original problem first. Square root of x minus 11 plus 16 outside of that radical equals 21. Okay, so we're going to plug 36 in for x. Square root of 36 minus 11 plus 16 equals 21. Reminder, we're not actually moving things around now. We're just trying to make sure that the left side turns out to be 21. Square root, 36 minus 11, that's going to be 25, plus 16 equals 21. Square root of 25, that is a perfect square, it's 5. 5 plus 16 equals 21. 5 plus 16 is 21. So that worked. So, x does equal 36. That is the correct answer. My solution worked. Also, I do want to add, if you happen to have the check fail, that doesn't always imply no solution. That could just mean you made a mistake. So before you jump to no solution, you might want to check over your work one more time before you make that decision. Just wanted to throw that out there. Okay, number 18. So normally, we would try to get our square roots by themselves, but we are already there. So, we get to go ahead and start by squaring both sides. Remember, the square cancels out the square root. So now we just have 8x plus 3 equals 13x minus 22. And this looks like just a normal equation that we're used to solving, so this isn't too bad. Remember, when you have this setup where you have constants on both sides and an x on both sides, I like to get rid of one of the x's first, so let's do that first. Move the smaller one to avoid a negative. So we'll subtract 8x on both sides. That cancels. Bring down the 3. 13 minus 8 is 5. Bring down that negative 22. Now we're going to solve for x. I'm going to move the 22 over by adding it. 3 plus 22 is 25. And then lastly, divide by 5 to get x. 25 divided by 5 is just 5. 5's cancel. X is 5. Okay, time to check. Check, x equals 5. We're going to plug it into the original problem. Square root of 8x plus 3 equals the square root of 13x minus 22. Now remember, if you have multiple x's, you plug that in to all of the x's, not just one or the other. So we have 8 times 5 plus 3 equals 13 times 5 minus 22. 8 times 5 is 40. We have 40 plus 3. 13 times 5, that's 65. You can use your calculator for that, of course. Left side, 40 plus 3, well, that's 43. Right side, 65 minus 22, that is 43 as well. I got the same thing on both sides, so that is good. My x does, in fact, equal 5. Number 19. X plus 9 cubed equals 216. There are a couple approaches you can use here. I'm going to kind of cheat, if you will. When you have an exponent, if you want to get rid of it, you just do the reciprocal. Now this is a 3. Hey, let me back up. Our original goal would be to get this by itself, but that we already get there. So let's get rid of the exponent. This is like a 3 over 1. So to get rid of it, we can raise it to the 1/3 power. And then I can do that to my 216 as well. Remember, what you do to one side, you do to the other. Now these cancel, so I'm left with x plus 9. Calculator for this part. Remember, with this calculator in particular, you type in your numbers, so 216, and then your caret, and then with fractions, it is absolutely necessary to use parentheses around it. If you don't use parentheses, it will be wrong. 1 divided by 3, and then end parenthesis, 6. If you have a different calculator and you still haven't figured out how to type this in, please come see me and I can figure it out with you. Now we solve for x. Subtract 9. X equals -3. Now I'm not going to show it here, but another option to get rid of this is to take the cube root, because the opposite of cubing is cube root. The problem is I haven't shown you how to do cube root in your calculator. I unfortunately on the next page will have to show you cube root. I don't really have an option, so I will be showing that later. So if you did the cube root, it still works, and if you know how to cube root in your calculator, it should come out to be 6 as well. So stay tuned for that explanation later. But this is how I did it to get around that, because I've shown you how to use the fraction button, or the fraction exponent in your calculator. All right, let's check. We always check. X equals -3. So our problem is x plus 9, and that was just cubed, equals 216. Plug in -3 for x, so we have -3 plus 9 cubed equals 216. Negative 3 plus 9, that is a positive 6 cubed, equals 216. And then in our calculator, we're just going to verify. 6 caret 3, it is 216. It worked. So x does equal negative 3. 3 problems left. All right, it keeps going in and out of focus. It'll eventually focus itself. So we are on number 20. The cube root of 15x plus 10 minus 8 equals negative 3. There, it started to go. Almost there. So first thing you want to do is figure out what you have to get by itself. The radical is what we need to get by itself here. So I'm going to start solving. To get this by itself, I need to move this negative 8 over here. So I'm going to add it. Those cancel. So now I have the cube root of 15x plus 10. Negative 3 plus 8, that is a positive 5. Be careful there. Now we have a cube root. The opposite of a cube root is cube. Opposite of cube root is cubing. And remember, you cube both sides. What you do to one side, you do to the other. The cube cancels out the roots, so we now have 15x plus 10 over here equals 5 cubed. You can do that in your calculator. That's a 125. And now we just solve for x. Minus 10 on both sides. 15x equals 115. And then divide by 15. X equals 115 over 15. Now let's check in our calculator. Can I divide this? 115 divided by 15. No, and on top of that, it's an ugly decimal, so please do not use the decimal. Don't round it. Fraction. Now, we can simplify, reduce this fraction, so let's do that. Hopefully, you can look at that and go, well, we can divide both of these by 5, because that is the number you need to divide by. So 115 divided by 5, that's going to give me 23. And then 15 divided by 5 is just a 3. And that is as much as we can simplify that. We cannot take a 3 out of both of those. So 23 over 3 is our answer. We have to check it, of course. So it's a maybe. Let's see. Check. X equals 23 over 3. Our problem is the cube root of 15x plus 10 minus 8 equals negative 3. Cube root of 15 times 23 over 3, don't worry, your calculator can do that part, plus 10, that's under the root, yep, minus 8 equals negative 3. All right. Still trying to get the under the radical worked out first. That's where I'm going to stay for a few steps. 15 times 23 over 3, we can easily type that in. So type it in exactly as you wrote it. If you write it correctly, that shouldn't be too bad. 15 parenthesis 23 divided by 3 parenthesis is 115. Plus 10, okay? Now we can add those. Cube root, 115 plus 10, that's 125. Minus 8 equals negative 3. Now here's where I have to show you how to use this. So hopefully by the time you're seeing this video, I've already shown you once in class. So this is not news to you. But if it is, here's how you do it. Now, reminder that this explanation works for my calculator specifically. So your calculator, well, there's a good chance it'll look very different. Some calculators, this is very easy to type in. This calculator is not one of those calculators. It's easy to type in. It's just weird. Okay. So first let me show you the button you're going to need to use for this. So if we look above the x squared button, you have a regular square root, and that's only a square root. You can't change the number. If I go one more button up, I've got the caret, and then above it, if you can see that, that is a root with an x in it. So that means I can change the number. Now what you have to do is you have to first tell the calculator which number is going to go in that spot. So since it's a 3, I'm going to type a 3 in. And then remember, to get to this, I have to hit second. You can see I've engaged the second now. So then when I press the caret, it's going to type in that. So this means cube root now. And then now I can type in what goes under that root, the root. For safe measure, go ahead and use parentheses when you type under it, just so it's clear. And then bring down the rest. Minus 8 equals negative 3. I'm going to do that one more time. For this, you need to see it. Well, I guess you could rewind, but I'm just going to do it anyway. 3, second, and then the caret button to get that root to pop up. So this is the cube root. And then just to be safe, 125. You get the 5. And so you can do this with any root, though we typically stick with a square root or a cube root. So square root, just use the square root button if you want. You could also do this, but we put a 2. Cube root, you have to do this. But we don't do this that often, so you won't need that very much. 5 minus 8 is negative 3. And we get negative 3, and it worked. So x equals 2/3, 23/3, let's try that again, is correct. That is my answer. 2 more problems. 6 times x plus 33 to the 1/3 power minus 24 equals 0. First, underline what needs to be isolated by itself. It's the bit in parentheses with the exponent. This does not include the 6. I'm going to have to get rid of the 6. So let's get that by itself first. Let's add the 24 over. Cancel. 6 parenthesis x plus 33 to the 1/3 power equals, well, that's just 24. Reminder, what I want is the bit in parentheses, not including the 6. Reminder, this relationship here is multiplication. So to get rid of the 6, I have to divide it. Do not be the person that subtracts the 6 off. It does not work that way. Divide by 6 on both sides. 6 is canceled. Bring this down. X plus 33, still in parentheses, to the 1/3, equals, and then that's going to be 4. All right. This is finally by itself, so now I can get rid of that exponent. It's 1/3, so to get rid of it, I'm going to flip it, and it's going to be 3 over 1, or just 3. On this side, I'm just going to write 3. These cancel each other out, so the left side is just x plus 33. And then 4 cubed, you can use your calculator, that is 64. And now we solve for x. Subtract 33 on both sides. X equals 31. And now we check. We are checking x equals 31. Plug it into the original problem up top. 6 times x plus 33 to the 1/3 minus 24 equals 0. Plug in 6 times 31 plus 33 to the 1/3 minus 24 equals 0. Remember your order of operations. PEMDAS. Please excuse my dear Aunt Sally. Parentheses, exponents. And I've never really taken the time to clarify. You multiply or divide left to right. Add or subtract left to right. So these are a whichever one comes first. Just want to clarify that small detail. So parentheses, exponents, multiply or divide, whichever comes first, and then add or subtract. So that's what I'm following as I condense this down. Parentheses first, so I'm working inside of this parentheses, so I'm going to add these first. 6 and then 31 plus 33, that is 64. The 1/3 minus 24 equals 0. I took care of parentheses, so now I go to exponents. I need to figure out what this is. So I need to figure out what 64 to the 1/3 is. So I'm going to have 6 times whatever that number turns out to be. So then I have 64 caret, and then in parentheses, you have to do parentheses. 1 divided by 3. 4. So it's 6 times 4 minus 24 equals 0. So we've got multiplication and then subtraction. Multiplication comes before subtraction. So multiply 6 times 4 is 24 minus 24, and that does in fact equal 0. So x does equal 31. All right, last problem. Number 22. 2x minus 13 to the 4/3 plus 9 equals 25. Again, underline what we are going to isolate, what we're going to get by itself. So that bit in parentheses with the exponent. So let's do that first. That's going to be our first goal. Move the 9 over here. We're going to subtract it. I'm going to bring this down. 2x minus 13 to the 4/3 equals 25 minus 9, that's 16. Okay, this is by itself, so now we can get rid of the exponent. It's a fraction, 4/3, so we can get rid of it by raising it to another exponent, and we just flip it, the reciprocal, 3/4. Do it on both sides. Don't forget to do it on both sides. These cancel, so that's just 2x minus 13. 16 to the 3/4, so I'll need my calculator for that. 16 caret, and then in parentheses, you can't forget, 3 divided by 4, parentheses, we get 8. And now we keep solving for x. Add 13. 2x equals 21. Not even, so we are going to have a decimal here. Divide by 2. X equals 21 over 2. Now, if you check with your calculator, 21 divided by 2. This is a nice decimal, 10.5. So this is a decimal where if you want to write, if you want this to be your answer, go for it. When I check, I actually prefer a decimal if I can, because that's easier to type into the calculator, in my opinion. So, either one is correct in this case. Don't round this, just use it. And we check. So for the check, I will use the decimal since that's a little easier. Check, we plug it into the original problem. 2x minus 13 to the 4/3 plus 9 equals 25. Plug in for x, 2 times 10.5 minus 13 to the 4/3 plus 9 equals 25. Again, using order of operations here. So working inside the parentheses first, I'm going to multiply these before I subtract. 2 times 10.5, you can use your calculator, that's 21. Minus 13 to the 4/3. And then just bring everything down. Now I'm going to subtract inside the parentheses. 21 minus 13, that's just 8 to the 4/3 plus 9 equals 25. Calculator for the exponent. Exponent comes next. 8 caret, you have to use parentheses, 4 divided by 3. 16. 16 plus 9. And 16 plus 9 is 25. So it worked. My answer is right. Again, you can use either of these, so I'm just going to put one big box around here. You don't have to write both. Write one of them down, whichever one you want to use. Okay, the study guide is complete. Hopefully this video was helpful. Feel free to watch and rewatch all of it, or specific parts, whatever you need to do for it to make more sense. Hopefully I answered any questions you have. If I didn't, feel free to reach out to me via email, or even better, come see me in person before you take your test. Otherwise, I will see you guys later. Have a great day. Bye.